Today our focus is going to be on naming ionic compounds. So we're going to be writing chemical names for these ionic compounds, and we're going to apply Roman numerals using something called the stock system. Also in class we're going to work on interpreting IUPAC names to develop chemical formulas. IUPAC, which is the way that we're going to use their system to name compounds, is called the International Union of Pure and Applied Chemistry. Now, while I have many jobs now, they also determine guidelines and standards for naming various chemical elements and compounds. And I point out the word IUPAC just because it's going to show up on Regents questions and that type of thing. So naming binary compounds. Binary compounds are ones with two elements. We're going to write the name of the positive ion first, and then when we write the name of the negative ion, we're going to change the name of the second element to end with IDE. So some examples of this I have here. Let me get this pen to show up. This first one, we have calcium and fluorine in our binary compound. So we're going to write the name, okay, for calcium first. We have calcium. Now calcium only has one positive charge, that's why we're able to follow this system. It can only be +2. So we write calcium, and then instead of fluorine, we're going to write fluoride. Okay, so we have IDE at the end. Here we have aluminum and sulfur. So aluminum only has one possible positive charge, so we can just simply write aluminum. And then sulfur goes to sulfide. Again, changing sulfur to end with IDE, so we're dropping the UR. So you have calcium fluoride and aluminum sulfide. So again, writing the positive ion followed by the negative ion, changing the ending to IDE. All right, now one thing I want to point out, and this is not in your note packet, is that if a compound name ends in IDE, it's usually a binary compound. However, you have to be careful with polyatomic ions. Polyatomic ions themselves are not compounds, and these are some just examples. If you look on table E, cyanide, peroxide, and hydroxide. So just be aware if you see those three that they're not actually an element, but that they are part of the polyatomic ions, and you're going to have to look at table E. All right, moving back to your note packet, naming ternary compounds. These are ones with at least 3 elements. You're going to follow the same rules as binary compounds. However, this indicates that we have a polyatomic ion. You're going to write the polyatomic ion name exactly as it appears on table E. Remember, we're not going to change it or add IDE. We're going to let it be. All right, so let's look at some examples. I put table E over here. Here we have our 3 elements. I'm going to have to look on table E. I know this is ionic because I have a metal here with a polyatomic ion. And you're going to see down here that we have sulfate. So I'm going to go ahead, I'm going to write the name of the first one, so magnesium. And then I just let it be and just write sulfate. Okay, you'll start to realize when we do a lot of practice that a lot of our polyatomic ions end in ATE or ITE, so it's one way to identify that you have one. All right, here we have a different example because NH4 is our polyatomic ion as the positive one. So in this case, we're going to write ammonium. Okay, and then oxygen is going to then be adjusted to oxide. Okay, so we are changing the oxygen because it is the negative ion to have the IDE ending. However, our polyatomic ion in this case was our positive one, so we just wrote ammonium. All right, now we've only dealt with positive ions that have one possible charge. So what happens when we have elements such as the transition metals that have more than one type? We use something called the stock system, where we're going to show the oxidation number or charge of the positive ion in Roman numerals. So here are the Roman numerals. Usually we only need to work up to, like 1 through 4, maybe 1 through 5, but really just 1 through 4. So if you don't know the Roman numerals, I would suggest writing these down into your note packet so that you have them to refer to. And again, being able to use the 1, 2, 3, and 4 is crucial. All right, so why do we need to do this? Cobalt chloride could have the formula COCl2 or COCl3. So we can't just write cobalt chloride. It doesn't give us enough information. We need to know the oxidation number in order to write the formula. So in this case, chlorine, written second, most electronegative, is going to take a -1 charge. I have 2 of them. Oops, that should be negative. In order to equal 0, this has to be positive 2. I only have one cobalt, so positive 2 divided by 1 is positive 2. Okay, so this is the compound that has a positive 2 charge. Here, chlorine, again, each one is negative 1. I have 3 of them, which means negative 3 charge on this side, which means this cobalt is my positive 3. Okay, so how I differentiate these is by using a Roman numeral to show which formula goes with which oxidation number. So I'm going to write cobalt like I normally would. Again, cobalt has more than one possible oxidation number. You can see that here. I can't just pick from the list, I have to use the formula. So I'm going to show a Roman numeral 2 to indicate the positive 2 oxidation number, and then I write chloride. Here I would write the same thing, cobalt, except I'm now going to show the Roman numeral 3 because it has a positive 3 oxidation number, and then I simply write chloride again. So again, any of these metals particularly, or any positive oxidation number element that has more than one, we can't just pick from the list. Okay, we're going to have to use the formula to calculate the number and then show that as a Roman numeral. And we'll be doing a lot of practice with that. So just some quick things about the Roman numeral. It only applies to the first element. Okay, it's only when the first element has more than one choice of oxidation numbers listed, and it's only ever used in word names. We never actually use it as a subscript. All right, so at this point, Regents, you are all set. You can just look over your notes. Honors, you're going to actually continue on. This will be a good test to see who went all the way to the end of the video. So one other thing that you guys need to be aware of with ionic compounds is something called the classic naming system, or the Latin root suffix method. I want you to either put this on the back of your note packet cover, or you can just put it on a separate page and attach it to your note packet. So what is this? Well, it's an old naming system, classic, that was used to name the positive ion that has more than one possible charge or oxidation number. Similar rationale to the stock system. So we're going to use the Latin root for the positive ion, and I'm going to show you that on the next slide. And then we're going to add the following suffix. We're going to use the periodic table. If it's the first positive charge listed, we're going to use OUS. If it's the second possible charge listed, I'm going to add on IC. The negative ion stays the same with IDE. So what are those Latin roots? These ones are the ones that you need to know because they don't match up with the name of the element as well, except for mercury. However, copper is CUPR. Iron, we're going to use FERR, and you can kind of see where now the chemical symbol came from. Tin is going to be STAN, STANN, and lead is PLUMB. So let's put these together, show you some examples, and I would definitely suggest writing these down. And again, you can see here, these 5 elements in particular have their 2 options, okay, for oxidation numbers. The top one we're going to use, again, the OUS, the bottom one is IC. So when copper has a positive 1 charge, it's going to be cuprous, and then the positive 2 is cupric. Okay, iron, we're combining again, and you can see here, this is our root, and then this is the suffix based on the charge. Okay, here again we have iron, so the FERR, and then adding on us or ic. So ferrous or ferric. Mercurous or mercuric. Stannous and stannic, and then plumbous and plumbic. So these are again all the classic naming systems. We can use this for our other transition elements or other metals that have more than one oxidation number, but these are the ones that don't match up to the element's name, so I want you to make sure you know them, and this is something that you're going to have to memorize. Some other examples that you should be aware of, here we have some nonmetals that have multiple positive oxidation numbers. So carbon goes to carbonous oxide, so normally we would name this, with say Roman numerals of carbon 2 oxide, but here we can do this as carbonous oxides because this takes on a +2, which is the first positive charge listed on the periodic table. All right, here we have carbonic oxide. That's because oxygen with a -2 times 2 means that carbon is +4, which is the second positive oxidation number. And then for sulfur, this is our sulfuric oxide, and that's because sulfur here takes on a +6. So check your periodic table and you'll see that that matches up with the second positive oxidation number for sulfur. So we will practice all these different types of naming systems for ionic compounds in class tomorrow. Just get down the general idea for this new system, well, not new to you, but this old classic system of these Latin root and suffix. So I will be checking this as part of your notes, so make sure you have this written down on the back of your cover or on a separate sheet to attach to your note packet. So now you guys are all set.